Yes, are you with me, students?
Yes, ma'am.
Okay,
Yes,
बेटा. तुझ्या आवाजातच कसं येतंय? Yes, madam. ठीक है. चलो स्टार्ट करते हैं, कोई बात नहीं. थोड़ा जल्दी खत्म करेंगे आज का टॉपिक. आप जल्दी जल्दी लिखो तो जल्दी खत्म होगा. Is the screen visible to you?
Yes, ma'am.
yes,
Okay, Bharat. Thank you, beta. So
Yes, ma'am.
students are joining. So please ask student to join first. Meanwhile, we will take recap of last lecture. So in the last lecture, you have studied the time domain specifications, or you can say derivation of parameters in time domain. What are the parameters in time domain analysis for second order system? Rise time, peak time, maximum overshoot, then settling time. All these are, you can say, specifications or parameters in time domain analysis. Okay, for second order system. So yesterday you have derived the equation for rise time. So for rise time, again I am repeating the same thing. Just write down the equations for rise time. You are going to solve the numerical based on this. So rise time, TR is equal to, rise time is denoted by letter capital T suffix R, is equal to pi minus theta divided by omega n under root of 1 minus zeta square. So first equation, first parameter or first specification of time domain analysis, okay, for second order system. Then you have derived the equation for tan theta. Tan theta is equal to under root of 1 minus zeta divided by zeta. Okay, so just by taking the derivative of your C of t, okay, and equating that derivative is equal to 0, simplifying further, we got this equation. Okay, this is the equation, right? So then you have derived the equation for TP. What is TP? TP is nothing but peak time. So you have derived the equation for TP. TP is equal to pi divided by omega d. Omega d is damp frequency. What is omega d? Omega d is equal to omega n into under root of 1 minus zeta square. So your equation for the next parameter or specification in time domain analysis, TP, peak time, is equal to pi divided by omega n into under root of 1 minus zeta square. So student, you are supposed to write this equation. Now, after that, you have derived the equation for percentage overshoot by using the standard equation. Okay, C infinity, this C infinity is nothing but final value of your output, and CTP is nothing but maximum value of output. So maximum value of output minus final value of output divided by final value of output into 100, you will get percentage overshoot. Okay, so that you have derived the equation for that. Okay. Now, just a second. So you have derived all these things, and you will come to know from slide number 24, beta is equal to under root of 1 minus zeta square, and sine theta is equal to under root of 1 minus zeta square. Okay, so you have to write all these steps. That is nothing but simplification. Then you got the equation for maximum overshoot. MP is equal to e raised to the power minus pi into zeta divided by under root of 1 minus zeta square into 100. Okay, for percentage. Then for given the value of overshoot in percentage, what is zeta? The damping ratio can be solved from the above equation, from this equation, just by taking natural log of percentage overshoot divided by 100 and divided by under root of pi square plus natural log square into bracket percentage overshoot divided by 100. So you will get the value of zeta for given overshoot in percentage. Okay, so this much you have studied in last lecture. Okay, now the last parameter is remaining, that is nothing but settling time. So student, please give the heading settling time, denoted by letter capital T suffix S. Just a minute, admitting in car 52. So please give the heading. Settling time. Last parameter. Now, what is settling time? The settling time is the time required for the amplitude of the sinusoidal signal to decay to 2% of the steady state value. Suppose maximum value is 1 असेल, so 2% of steady state value is nothing but on lower side it is 98%, on upper side it is 102%, right? Of the steady state value. So in order to find the settling time, we must find the time for which this output, that is nothing but C of t, reaches and stays within plus minus 2%. Hence I have taken 98, that means minus 2%, and 102, that is plus 2% of steady state value. Steady state value is nothing but final value of your output, C final. The settling time is the time it takes for the amplitude of the decaying sinusoid in C of t to reach up to 0.02. Or you can write the equation for settling time by using this equation, that is e raised to the power minus zeta omega n into ts. Ts is settling time into 1 divided by under root of 1 minus zeta square is equal to 0.02. Now simplify this equation, you will get equation for settling time by taking natural log on both the side. You can write the final equation for, you have to write this equation. Student, you are supposed to write this equation. Take log on both the side, simplify, you will get equation for settling time. Ts is equal to 4 divided by zeta into omega n. So this is the equation for fourth specification or parameter in time domain analysis. So student, you are supposed to write this equation. You are going to solve the numerical based on all four equations you got. You have derived the equation for all four parameters, four specification in time domain analysis. Okay, are you with me up to this?
Yes.
Yes, ma'am.
Okay, beta. So you are supposed to write all these equations and do the simplification. In between, I have not written any step. So I have given that small homework to you. Okay. कसं करायचं हे मी सांगितलंय मुलांना. So please do it. So the equation for Ts is equal to 4 divided by omega n into zeta. So this much you have studied in last lecture. Agree? हो ना, इथपर्यंत आपण शिकलोय लास्ट लेक्चरला. Yes, are you with me students? हा, ओके बेटा. सो हे मी रिवाइज केलंय हा मुलांनो तुमच्यासाठी. Now give the heading. For different values of zeta, we are going to observe the response of second order system. Okay. आता काय करणार मी झीटाची व्हॅल्यू घेणार आहे. Zeta is equal to 1, zeta is equal to 0, zeta is greater than 1, zeta is lying between 0 to 1 or less than 1, and I am going to show you the response for different values of zeta. 4 category आहे की नाही zeta? Yes, are you with me? हो ना, आपण बघितलं ना 4 category of zeta. Just wait, admitting student. Student, please give me feedback in between. Something is written, ma'am. Please, could you check the waiting room? Okay, Shyam. Thank you. Admitted. Now, 53 students are here. Out of 79, only 53. चलो कोई बात नहीं. हाँ. So in summary, you have to write all these equations. चला summary मध्ये हे equation लिहून टाका सगळे. Give the heading. Second order system. Time domain specification. Write the equation for settling time. Write the equation for maximum overshoot. Write the equation for TP, omega D. What is remaining? Rise time. So all equation you are going to write in your notebook. चला लिहिले का हे 5 equations तुम्ही. Now depending on value of zeta. Moving forward. Yes, are you with me, students?
Yes, ma'am.
Swela. Okay, beta. Thank you. So out of 53 students, only one is replying. All should be here, students. Now, interesting topic is going on. Example. Write the example. Through example, we will see the effect of zeta. हे दाखवणार आहे मी तुम्हाला. Is this screen visible? What is written on screen?
Yes.
Underdamped system. काय लिहिलंय? Underdamped system, right? Example is given. Write this example. Find the natural frequency and damping ratio of the given system with this transfer function. What is given transfer function? G of s is equal to 36 divided by s square plus 4.2s plus 36. Lihila equation. Now what is first step? Yes, what is first step? Observe the equation carefully. Observe the equation carefully. This is the equation for transfer function for second order system. Now we are going to compare this equation with standard equation, okay, of second order system. So what is standard equation of second order system? G of s is equal to omega n square divided by s square plus 2 zeta omega n into s plus omega n square. Second step. काय आहे आपली second step? You are going to find the value of omega n. You are going to find the value of zeta. Find natural frequency omega n. Find damping ratio zeta from the given transfer function. So compare this equation with this given equation of transfer function with standard equation of second order system. Standard equation of transfer function equation for second order system. Okay. So omega n square is equal to 36, right? By comparing these two equations, what we got? We got omega n square is equal to 36. What is omega n? Hence, omega n is equal to under root of 36. Under root 36 is nothing but 6. So you can write the value for omega n in square bracket like this. Omega n is equal to 6. That we got. Natural frequency omega n is equal to 6. Just wait, I will just do that. Then find out damping factor, damping ratio, that is nothing but zeta. Okay. After comparing these two equations, what we got? We got this term. Okay. 2 zeta omega n is equal to 4.2. Right? Is equal to 4.2. Now simplify. Omega n is equal to 6. Put the value of omega n in this equation. Find out zeta. Zeta is equal to this equation. Please do it. Zeta is equal to 0.35. So all of you got the equation? Value of omega n and zeta. Please do it. How much you got the value? Take the calculator, do the calculation. काय करायचं calculation आपल्याला? 2 zeta omega n is equal to 4.2. Now you know the value of omega n. Omega n is equal to 6, right? So 6 into 2, 12. So 4.2 divided by 12. How much you got? 0.35 is nothing but value of damping ratio zeta. Are you with me, students? Such
Yes,
example may, okay, beta, thank you, Bharat. So such an example may ask in examination, okay, for 2 marks. Now, all are here? Have you got the same value? Zeta is equal to 0.35. You have to write your final answer in square bracket. Then omega n is equal to 6. चलो आगे चले.
Yes, ma'am.
Okay.
Yes, ma'am.
Next example. नहीं आ रहा है सेकंड एग्जांपल जीटा हो गया, फर्स्ट एग्जांपल तो ये हो गया, ये एग्जांपल सेकंड है, थर्ड एग्जांपल चलो। Now here again transfer function is given. Okay, so given transfer function is nothing but transfer function for second order system if you observe it carefully, and you are going to find TS, that is settling time, percentage overshoot, and peak time PP. Okay, so what is first step? Again, compare your given equation of transfer function with standard equation of transfer function in second order system. That is nothing but we are going to compare this equation with equation that is nothing but omega n square divided by s square plus 2 omega n zeta into s plus 100, that is omega n square again. Okay, so what is the value of omega n and zeta? Second step, find out omega n is equal to under root of 100. Under root of 100 is nothing but 10. So natural frequency omega n is equal to 10. What is zeta? Yes, 2 zeta omega n is equal to 15. We are having omega n is equal to 10. So zeta is equal to 0.75. All of you got the same value?
Yes, ma'am.
Okay, beta. So 15 divided by how much? 10 into 2, 20. So 0.75 is nothing but value of your damping ratio or damping factor. Okay. Now you are having value of natural frequency, value of damping factor, that is omega n and zeta. Okay. Put this value in the equation. You are having equation for settling time TS. What is TS? What is equation for TS? 4 divided by zeta into omega n. Right? Yes, are you with me, students? And unit is second.
Yes, ma'am.
Yes, ma'am.
First write the equation, then put the value 4 divided by, first write TS is equal to 4 divided by zeta into omega n. Next step, TS is equal to 4 divided by 10 into 0.75. Do the calculation. You'll get value for settling time is equal to TS is equal to 0.533. S means seconds. Or write SEC, seconds. So this is your answer. You can write your answer in square bracket. This is zeta. So how many students got the answer for settling time? TS. Admitting students. Are you with me, students, up to this?
Yes, ma'am.
Okay.
Yes, ma'am.
Very good, very good. अच्छी बात है. चलो आगे चलते हैं. अभी मैक्सिमम ओवरशूट. हाँ. What is the equation for maximum overshoot? Please write that equation. Put the value of omega n and zeta in that equation. Simplify, calculate. You will get percentage overshoot is equal to 2.838%. Do the calculation and let me know whether the answer is correct or not. So this is the value for maximum overshoot. Are you with me up to this? Then third, write the equation for peak time. What is the equation for peak time? बोला summary मध्ये लिहिलंय तुम्ही. What is the equation for peak time?
Pi upon omega d.
Okay, so put the equation, put the value. Omega d is equal to omega n into under root of 1 minus zeta square, right? So pi divided by 10 into under root of 1 minus 0.75 square, bracket complete. Do the calculation, you will get equation for peak time is equal to 0.47475 seconds हा इथे पण टाइम जे काही आहे that is in seconds. Okay, all of you got the values? Please cross check your answer. It's very simple actually. Something is written chat box. Yes, madam. Okay, beta. So all of you got the values?
Yes, ma'am.
Okay, very good. You are doing calculations. Thank you. So, who is in waiting room? Sahil. Huh. So you have to write final answer in this way. Omega n is equal to 10, zeta is equal to 0.75, settling time TS is equal to 0.533 in seconds. Then percentage overshoot is equal to 2.838%. Then peak time TP is equal to 0.475 seconds. Right? Now proceed further. Chalo, आगे चलते हैं. So we have solved examples, 3 examples. Now let us see the response for underdamped system. Underdamped means zeta is, बोला मुलांनो, अंडरडैम्प सिस्टम में क्या होता है जीटा का वैल्यू? यस, अंडरडैम्प सिस्टम व्हाट इज वैल्यू ऑफ जीटा? आपण कॅटेगरी बघितलं ना मुलांनो? Please write the sentence for underdamped system. What is value of damping ratio zeta? Answer तुम्ही द्यायचा आहे हा मुलांनो. Now this is the second order
Between
system
0 to
response
1.
specifications I am going to tell you. So this is the response. Response means for step input, your second order system is responding like this. So on x-axis I have taken time in seconds. Okay. On y-axis I have taken output, that is C of t. This is nothing but maximum output, C max, this point. Okay. This point is nothing but 100% of maximum, 100%, or क्या से काय म्हणतो आपण त्याला शेवटची final value. Okay, C final. Then below that I have shown, एक मिनट थोडंसं enlarge करते हैं. Is it visible clearly?
Yes, ma'am.
हाँ, बघा. Below that one line I have drawn dotted line, that is nothing but for 98%, and above 100% one more dotted line is there, that is for 102%. That means settling time is varying from 98% to 102%. That is nothing but plus minus 2%. Okay, meaning is that now this point is nothing but 90% of maximum. Okay, this point is nothing but 10% of maximum. Okay, and this is the response for unit step function. Your second order system is responding like this for unit step function, and this is nothing but your settling time from this point to this point. It is 2% of final value. So you can write and like this. This much is nothing but settling time, 2%. एवढा जो आहे, म्हणून मी काय दाखवलं इथे 98% to 100%, that is minus 2%. 100% to 102%, that is plus 2%. Variation in settling time. Okay, now this much is nothing but your C max. Okay, at this point, and from this point 100% to C max is nothing but percentage overshoot. So this is nothing but percentage overshoot. कुठून होतोय बघा percentage overshoot, इथून तर इथपर्यंत. Okay, so हा जो पॉइंट आहे, हा एरिया, we are calling this as percentage overshoot. right? Now, time required for your system to reach to maximum value of output is nothing but peak time. हे बघा, हा जो आहे हा काय आहे TP, इथे लिहिलेलं आहे बघा TP, peak time. Now rise time. What is rise time? Rise time is nothing but time required for your system to reach from 10% of maximum to, आता 10% of maximum कुठे आहे? 10% of maximum to 90% of maximum is nothing but rise time. So कुठून कुठपर्यंत झालं आपला rise time बघा. Rise time is from 10% to from 10% to 90%. So your response is changing from 10% to rise percent, 90% is nothing but time required for your system or output changing or increasing from 10%, rising from 10% to 90% is nothing but rise time. Definition. Now settling time. Fourth parameter is settling time. So this much is nothing but your settling time. From this point to this point. Time required for your system to settle down is nothing but settling time. See, there are oscillations. Your response is changing starting from 0, having maximum overshoot or maximum output, then decreasing again, going to negative side, decreasing, again increasing from this point. Okay, but the amplitude of oscillations are, these are nothing but oscillations. Okay, these are nothing but oscillation. Again increasing, again decreasing. आता इथे बघा निगेटिव्ह साइडला परत डिक्रीज झालाय, and this is how your system is trying to settle. Okay, so up to this point, from starting up to this point is nothing but your settling time. Now after this settling time, your system is moving between steady state. That means between this 2% your output is changing. पण output कुठल्या रेंज मध्ये राहणार आहे? Between 98 to 102 only. And this much is nothing but your C final value of output with respect to time. And this is how you will get the response for second order system. So all these are the specifications for second order response specification. So second order response specifications are, first one is, yes, rise time, then peak time, then settling time, and maximum overshoot. Got my point? Understood?
Yes, ma'am.
Any doubt up to this? Any doubt, student?
No, ma'am.
Okay, चलो आगे चलते हैं. So draw the diagram. Write all these parameters. We are calling in some references this TS, TP, TR, and maximum overshoot. We are calling this as parameters or specifications. So don't confuse. What are the specifications? What are the parameters? Both are same. Either you can call specifications or parameters. Okay. So these are the 4 specifications for second order system. Okay. Response specification. Response म्हणजे हा response आहे. This is the response of second order system when unit step input is applied. Okay. So please remember this, and you are supposed to draw this along with specifications. चलो आगे चलते हैं. अभी देखते हैं categories of damping factor and response for that particular damping factor. First one, please give the heading. Overdamp response. So in overdamp response, what is value of zeta? In overdamp system?
Greater than.
Yes, zeta is greater than 1. Zeta is greater than 1. Damping ratio zeta is greater than 1 for overdamp system. Now let us see what happened for overdamp system. Okay. So what is our equation? Standard equation is G of S is equal to B divided by S square plus AS plus B, right? Now, this is the overdamped system with this transfer function equation. So what is equation for transfer function for overdamped system? When zeta is equal to greater than 1, zeta is greater than 1, 9 divided by S square plus 9S plus 9. So what is value of A? B is equal to 9, A is equal to 9. Okay. Now, take a minute. Is this clear now?
Ma'am.
Okay, beta. So please write the example when zeta is greater than 1. Zeta is greater than 1 means overdamped system or overdamped response. चलो अभी देखते हैं. So unit step input is applied. This C of S is nothing but output, right? And R of S is nothing but input. C of S is nothing but output. Now this is nothing but transfer function of your process. Okay. When zeta is greater than 1, that is overdamped system, we are going to find or we are going to observe the response of system. Okay. Now C of S is equal to R of S into G of S, right? What is equation? Standard equation. G of S is equal to ratio of C of S divided by R of S. Input applied is unit step input. So R of S is equal to 1 by S. Directly I have written over here. Now what is CS? CS is equal to GS into RS. So equation for CS is equal to G of S is 9 divided by S square plus 9S plus 9. So I have written G of S is equal to 9 divided by S square plus 9S plus 9. Okay. Into R of S. What is R of S? R of S is 1 by S. Into R of S, 1 by S. So I got this equation. C of S is equal to 9 divided by S into bracket S square plus 9S plus 9. Got my point?
Yes, ma'am.
Okay. Now, by using characteristics equation, you are going to find the roots of this equation, S square plus 9S plus 9. Find out. आता काय करायचं आपल्याला रूट्स काढायचे आहेत आपल्या इक्वेशनचे. आपलं इक्वेशन काय आहे? S square plus 9S plus 9. What are the roots? That is given in front of you, but you have to solve it. मी डायरेक्टली दिलंय मुलांना, पण तुम्हाला माहिती पाहिजे कसं काढायचे रूट्स. That I am not going to explain here. Okay, that is prerequisite. So the roots for this equation, 1 by S as it is, 9 constant as it is I have taken. Roots for this S square plus 9S plus 9 is equal to S plus 7.854. Second bracket, second root का है S plus 1.146. Okay. आता बघा. Now from this equation of output, that is nothing but C of S. Okay. So these are nothing but zeros. Numerator मध्ये जे काही लिहिलेलं असेल in terms of S, these are, we are calling these are zeros. Okay. And denominator मध्ये S term मध्ये जे काही लिहिलेलं असेल, that is nothing but poles. Okay. Poles. So these are poles. S plus 7.854 is equal to 0. S is equal to minus 7.854. First pole. Second root का है आपला S plus 1.146 is equal to 0. S is equal to minus 1.146. Second pole. So I have written, and for this S is equal to 0, right? So first pole is at S is equal to 0. Second pole is at S is equal to minus 7.854. Next pole S is equal to minus 1.146. So two real poles are available for this underdamped system. When zeta, for this overdamped system, when zeta is greater than 1. So only two poles are available and there is no any zeros. Okay. Are you with me up to this? इथपर्यंत समजलं मुलांना?
Yes, ma'am.
ओके बेटा. आता आपण पुढे जाऊया. आता रिस्पॉन्स बघायचा आपल्याला. वी आर गोइंग टू प्लॉट these poles on S plane. So S plane is divided into two parts, main parts, right half of S plane and left half of S plane. आता बघा आपले poles काय आहेत with negative sign. So we are having two real poles and one pole at S is equal to 0. We are going to plot these poles in on S plane. आता मायनस साइन ने आलेत म्हणजेच आपले पोल्स कुठे येणार आहेत मुलांना ऑन लेफ्ट हाफ ऑफ एस प्लेन. ऍग्री विथ दिस? कळताय का मुलांना? येस
Yes, ma'am.
ओके बेटा. हा बघा आता. हा
मॅम परत एकदा सांगा ना की लेफ्ट हाफला कसं.
हा इथे आता एक्सप्लेन करते. हे बघ लेफ्ट हाफला कसं येतात. एस इज इक्वल टू, नाउ दिस इज द इक्वेशन. हा by taking Laplace inverse of this, if you solve this equation, huh, 1 by s plus 1 by this factor plus 1 by this, okay, by partial fraction you will get constant value k1 k2 k3 that I have written directly, and after that you will get, after taking inverse Laplace of this equation, c of s चा inverse Laplace घेतला की काय येणार तुम्हाला, c of t is equal to k1 first constant plus k2 into e raised to the power minus 7.854 t plus k3 kaitari constant into e raised to the power minus 1.146 t. So this is the equation you will get after taking inverse Laplace of c of s. Okay, that you have to do. You have to do it. No other option. Now plotting the poles. So this is your S plane. Huh? Is it visible now? थोडंसं एनलार्ज केलं, व्यवस्थित दिसतंय का मुलांना?
येस मॅम.
Overdamped system, overdamped response. So we are having two poles. First pole at minus 1.147. So माझा first pole इथे आला. Pole आपण cross ने denote करतोय, right? And 0 ने denote करतोय, right? So this is S plane. On S plane, we are having real axis and imaginary axis. So this one is nothing but my real axis. या बाजूला जो आहे हा काय आहे माझा real axis. Okay. This is minus real axis on this side. This is imaginary axis, positive imaginary axis. On this downward side, minus imaginary axis, right? S plane चे 4 quadrants आहेत ना, लक्षात आलं? Always you have to refer this S plane because we are going to plot the poles for all 4 categories. First one I have taken for overdamped system, overdamped response when zeta is greater than 1. So we got 2 poles. Okay, एक pole कुठे येईल? S plus S is equal to 0, that means at this point. Okay, origin ला येईल. दुसरा pole कुठे आला आपला? S is equal to minus 1.145. So I got this pole. हा एक pole आला माझा. Add S is equal to minus 1.145. Real 2 poles मिळालेत आपल्याला, right? Second pole काय आहे माझा? S is equal to minus 7.854 at this point. Okay, 2 real poles we are having. Now observe the diagram carefully. S plane. So our poles are located in left half of, हे जे आहे, this much is nothing but this point. From this point to this point is nothing but left half of S plane. Left half of S plane. Okay, and on this side, इथून इथं काय असेल बघा, on this side, this is right half of S plane. Right half of S plane, right? So now observe the S plane carefully. Our poles, 2 real poles we are having, and 2 real poles are located in this area, in left half of S plane. Got my point? Students, please talk with me अंडरस्टूड?
Yes, ma'am.
ओके, सगळ्या मुलांना कळलंय का पोल्स कसे आपण लोकेट केले?
Yes, ma'am.
Okay, yes, thank you, beta. Now response. And this is nothing but response. I have taken time on x-axis. I have taken output on y-axis, and you will get response for your overdamped system like this when zeta is greater than 1. Okay, so draw the response, draw the S-plane diagram also for overdamped response when zeta is greater than 1. Okay, understood? Any doubt up to this? Any doubt up to this? Student, please respond. समजलंय का S-plane poles कसे आपण प्लॉट केले ते समजलंय?
Yes, ma'am.
ओके बेटा, थँक यू अथर्व. हा नीरज समजलंय? नीरज any doubt? नीरज any doubt? नीरज any doubt?
Neeraj, please mute yourself.
वैष्णवी समजलं? प्रसाद, प्रथमेश, मनीष, आशीष?
Yes, ma'am.
Okay, beta. Okay, thank you.
Yes, ma'am.
Okay, so this is how you got the response for overdamped system. Okay, when zeta is greater than 1. Okay, no doubt. चलो आगे चलते हैं. आता पुढची कॅटेगरी घेऊया. Underdamped response. Underdamped response means zeta is less than 1. Underdamped response when zeta is less than 1. Okay. At the same time, I have taken one more transfer function, and that is different. Here again compare this equation with the standard one, that is b divided by s square plus as plus b, right? What is a? A is equal to 3. So this is underdamped system. This is underdamped system. Okay. Again, unit step input is applied. R of s is equal to 1 by s. R of s is input. C of s is output. Okay. And system is underdamped system. At that time, your zeta is varying between 0 and 1. That's why I have written 0 less than zeta less than 1. That is underdamped system. Okay. Now, same procedure again. We are going to plot poles and response for underdamped system. Now, this is the transfer function equation. 9 divided by s square plus 3s plus 9. Okay. Unit step input is applied at the input side of your process. Output of your process is nothing but C of s, right? Unit step input आहे म्हणजे R of s काय झालं? 1 by s. Now, what is equation for C of s? C of s is equal to transfer function into unit input step input, that is R of s. So we got the equation for C of s is equal to R of s into G of s. Okay, so what is G of s? G of s is 9 divided by s square plus 3s plus 9 into R of s into 1 by s. So write the equation for CS. C of s, you are supposed to write C of s is equal to 1 by s into bracket into 9 divided by s square plus 3s plus 9. This is underdamped system. Now find out constant by partial fraction. First of all, you have to write roots for this. S square plus 3s plus 9. You will get 2 roots because power is s raised to 2. 2 roots are available. Okay. So find out roots. Then what you have to do? By partial fraction, you have to find constant k1, k2, k3. Then by taking inverse Laplace of that equation, you will get finally C of t is equal to k1 plus e raised to the power minus 1.5 into t into bracket K2 into cos of 2.598 into t plus K3 into sine of 2.598 into t, bracket complete. Now, find out poles and zeros. How many zeros are there? No zero. Only 9 is here in the transfer function. So no zeros. How many poles? 2 poles are available. बघा कुठल्या टाइपचे 2 poles आहेत बघा आता. रियल पार्ट काय आहे आपल्या पोल मध्ये? रियल पार्ट इज -1.5. What is imaginary part? Imaginary part is 2.598 is imaginary part. So we are having 2 complex poles. Complex poles we are writing in terms of rho plus and minus j omega. आपलं rho काय आलाय? -1.5 and आपलं omega काय आलाय? 2.598. Got my point? And one more pole at s is equal to 0. That is because of this term 1 by s. Got my point, students? So we are having 2 complex poles. Now how to locate these 2 complex poles? How to locate? In S-plane. Understood up to this point? Students?
Yes, ma'am.
Okay, beta. Now, plotting the poles on S-plane. बघा S-plane मध्ये pole plot केले आपण. First pole आहे आपलं. Real part काय आहे poleचा आपल्या? -1.5. So my real part on this line is minus, this is nothing but minus rho. On this side, this is plus rho. This is plus j omega. This is minus j omega. Okay, in this direction. Okay, s is equal to 0. One pole at origin. Second pole at -1 point s, real part, plus j 2.598 is here. So my pole is locating at this point. Okay, when real part is -1.5 and imaginary part is at plus 2.598. So my pole is lying over here. बरोबर? हा एक pole आला आपला. Again, pole is located at left half of S plane. Okay. Now second pole कुठे आहे आपला? Real part. Again same real part. -1.5. मग आपला pole कुठे आला बघा? इथे एक pole इथे आला -1.5. Okay. And imaginary part का आहे? -2.598. So this is my -2.598 on imaginary axis. So my pole is located over here. This is S2 is equal to -1.5 minus j 2.598. And my S1 -1.5 plus 2.598 j. So this is how you are going to locate your poles in S plane. कळलं का मुलांना? Got my point? Understood? Okay, beta Pratham. Thank you. Now this is nothing but response of underdamped system. बघा underdamped system चा response बघा. Overdamped system मध्ये तुमची system इथूनच stable झाली होती, right? There is no any overshoot. For underdamped system, your response is going above 100%. So you got over here overshoot. Your system is oscillating, meaning is that system is oscillating. Up to this point, it is transient response. After this point, it is steady state response. So this is how you can analyze your underdamped response. Got my point? Understood? Any doubt up to this? Any doubt, students? Ashish, Vaishnavi, Prasad, Sanskar, Lokesh, Shravani कुठे आहे?
No, ma'am. No doubt.
Okay, beta. Remaining students got my point. Understood?
Yes, ma'am.
Yes, ma'am.
Okay. Thank you, beta. Vaishnavi, thank you. Chat box मध्ये काही question आहे का? Prasad, thank you beta. Bharat, thank you. So we'll stop here. So student, today you have studied about second order system. I have taken 2 example, okay? And then I have explained about overdamp response, how to locate the poles for overdamp response when zeta is greater than 1. Then second, I have taken second category, that is underdamp response. At that time, zeta is less than 1 or lying between 0 to 1. So we have located the poles on S-plane. Here also for overdamp system and underdamp system, we have located poles on S-plane. In both the cases, poles are located in the left half of S-plane. And we have observed the response with respect to time. That means your output is changing with respect to time. So this is the response for overdamp and underdamp system. This much you have studied in today's lecture. Okay, thank you students for attending the lecture. Thank you all. If you are having any doubt, yes. If you are having any doubt, you can ask me, you can write in chat box also. Thank you all. Please write your roll number with understanding in chat box, then you are free to move. Thank you. Any doubt, students? Any doubt, students? So let joining student, please let me know your number.